This is Algebra 2 lesson 1-6, absolute value equations and inequalities. Absolute value is the physical distance a number is from zero on the number line. Since physical distance can never be negative, the absolute value of a number is never negative. I can't take the absolute value. I can't get the absolute value of 6 being negative 6 because I cannot go negative 6 units. I can go 6 units in the opposite direction. Direction determines the negativity of a number. Okay? So absolute value is physical distance. So 6 units to the left of 0 on the number line is negative 6, but its absolute value is 6 because I went 6 units. An extraneous solution is a solution derived from the original equation that is not a solution to the original equation. It's derived from the original, and we get a solution, but it's not a solution to the original. And I'll explain what that means in more detail later. So absolute value, just in case you don't remember, the absolute value symbol is this. The absolute value is negative 6 equals 6. Okay? An absolute value equation has a variable within the absolute value sign. For example, the absolute value of x equals 5. The value of x can be 5 or negative 5. Since the absolute value of 5 and the absolute value of negative 5 both equal 5. So when you solve an absolute value equation or a multi-step absolute value equation, the first thing you want to do is you want to set it up properly. Based on the fact that this has 2 answers, you need to set up your equation, which has with an absolute value, to equal to the positive and to the negative of something. For example, if I'm going to solve the absolute value of 2x plus 5 equals 9, I'm going to set this up 2 different ways because I can have 2 different solutions. I have 2x plus 5 equals 9, or 2x plus 5 equals negative 9. Notice when I set it up, the absolute value symbols go away. Okay, so now that I'm solving this, I can solve it 2 times. I have to solve both equations. So I subtract 5, subtract 5, and I get 2x equals 4, so x equals 2. Here I'll subtract 5, 2x equals negative 14, and 2, x equals negative 7. So the answer here is x can equal 2 or x equals negative 7. And again, you can check these going back into your equation. You should always check them to make sure that they're right. So let's check these really good. We use 2. We have the absolute value of 2 times 2 plus 5 equals 9. So 4 plus 5 does indeed equal 9, so that was a check. Use negative 7. 2 times negative 7 plus 5. That's going to be negative 14 plus 5. The absolute value of negative 14 plus 5 is going to be the absolute value of negative 9. The absolute value of negative 9 does equal 9, so that checks as well. Let's look at letter B. The absolute value of 4 minus 2y plus 5 equals 9. Before we can set this up to equal a positive and to equal a negative, we need to make sure that the only thing on one side of the equation is the absolute value symbol. That's very critical. So we can't set this up to be equaling to 9 and negative 9 until we subtract this 5. So we'll subtract the 5 from both sides. Now we have 4 minus 2y, and the absolute value symbol is equal to 4. So now we can set it up. So 4 minus 2y equals 4, or 4 minus 2y equals negative 4. So subtract 4 here. I get negative 2y equals 0, divided by 2, and y equals 0. Or subtract 4 here. You get negative 2y equals negative 8, divided by 2, y equals 4. So my answers are 0 and 4. Now, since we've already discussed the fact that distance from 0 on the number line cannot be negative, therefore some absolute value equations have no solutions. It's important to check your possible solutions of an absolute value equation because one or more of the possible solutions might be what we call extraneous. Let's take a look at the following examples. Letter C. The absolute value of negative 2x plus 9 equals 3x plus 10. To solve this, we have to solve it 2 ways. we have to set up negative 2x plus 9 equals 3x plus 10. That's the positive of it. Then we have to solve the negative of it. Now be careful when we set up the negative of this. I'm going to set up the negative in red so that you can see the differences between the two equations. We keep the negative 2x plus 9, but we have to make it equal to parentheses. Make sure the negative sign goes outside of the 3x plus 10 so that the entire thing becomes negative. Okay, let's solve the first equation. So we subtract 9, subtract 9, subtract 3x, subtract 3x. 9 cancels, 3x cancels. I get negative 5x equals 1. Divide by negative 5, divide by negative 5. X equals negative 1/5. There's one possible solution. Over here, 2x plus 9 equals negative 3x equals 10. So I'm going to add 3x, subtract 9, subtract 9. So I'm going to get negative x, let's cancel out, equals negative 19. So x equals 19. So I have two possible solutions here. Okay. I have set plenty of positive x. Excuse me, I made a mistake. There was going to be positive x equals negative 19. So x can equal negative 19. Now I need to check both of these. And I'll give myself lots and lots of space to move up and down. Remember, my original equation was this. The absolute value of negative 2x plus 9 is going to equal 3x plus 10. I need to check and see if my solutions work. Okay, so I'm going to check negative 1/5. So I'm going to take the absolute value of negative 2 over 1 times negative 1/5 plus 9. Does that equal 3 over 1 times negative 1/5 plus 10? Okay, I'm just going to multiply straight across the top, straight across the bottom. So this is going to be positive 2/5 plus 9, which is 9 2/5. It's 9 2/5. Does that equal? Here we're going to have negative 3/5 plus 10. Well, 10 minus 3/5 is 9 2/5. That one checks, no problem. Let's check the negative 19. Right, same equation. I'm going to do the same thing. I'm going to have outside of negative 2 times negative 19 plus 9. Does that equal 3 times negative 19 plus 10? Negative 19 times negative 2 is positive 38. So 38 plus 9 is 47. That's the value of 47. Does that equal? Negative 19 times 3. Okay, let's see, 57. Negative 57 equals 10. So I have the absolute value of 47, which is 47. It does not equal negative 47. So negative 19 is what we would call an extraneous solution. It solves the solution, the equation. It solves this equation just fine, but it does not solve our original equation of the 2x. This absolute value of negative 2x plus 9 equals 3x plus 10. So that's what we call an extraneous solution. And with extraneous solutions, you obviously can't use them. So the only solution that works with this particular equation is x equals negative 5, because the other one is extraneous. I'm just going to skip this next example. I don't need it. I'm just going to leave it off. Now let's go to the next question. Now, we've done absolute values of inequalities before. Some of you may or may not remember these, but let's just refresh your memory. The solutions of the absolute value of the inequality. The absolute value is less than 5. Means it includes all values that are less than 5 units away from 0 on the number line. Okay, so less than 5 units away from 0 is going to be greater than negative 5, but less than positive 5. Because on a number line, if I said the absolute value is less than 5, if I have this number here, here's 0, and say this is negative 5, this is positive 5. If they're less than 5 units away from 0, they've got to be between these two numbers here, not including those two numbers. That's what that means. So essentially what we do is we get the absolute value inequalities can be written in a special form. To solve an inequality in the form of the absolute value of A is less than B, it's going to be an AND equation, okay, as long as B is greater than 0. It's going to be the absolute value of A, when you get the absolute value of A is less than B, A is greater than negative B, but less than B. If you get the absolute value of A is greater than B, you get A is less than negative B, or A is greater than B. These are the things that you need to know. This here, I'll highlight this here, this, and this. Okay? So actually, let's just do this. If it's absolute value of A is less than B, it solves that equation right there. A is less than negative B, but at the same time, greater than negative B, but less than B. If you get absolute value of A is greater than B, you get the absolute value of A is less than negative B, or the absolute value of A is greater than B. Easiest way to remember this. Stupid, but works. Less than is an AND. Greater is greater is an OR. If it's a less than, make it an AND equation. If it's a greater, make it an OR equation. That's the way I remember them, and it makes it pretty simple for me. So let's take a look at this. Solve and graph the absolute value of 4x plus 3 is less than 5. Less than is an AND. This is an AND equation. Okay, so I'm going to write it as an AND equation. I'm going to write what the highlighted green is up there. I'm going to put what's in the middle. The A part goes in the middle. 4x plus 3. It's greater than negative 5, but less than 5. Notice the 5 goes here, the 5 goes there. This one has a negative, this one does not. The symbol stays the same. So the symbol stays the same all the way through it. Here, okay, oops, I'm messing it up. Right. The symbol stays the same. Okay, if we look at this, notice how our symbol is the same here, and our symbol is the same there. So now I'm going to solve this equation. I'm rewriting it neat and tight here. It's really ugly now. Negative 5 is less than 4x plus 3, which is less than 5. Now I need to isolate the 4x. Get the 4x in the middle all by itself. So subtract from here, subtract from here, subtract from here, because essentially there are 3 sides to this equation. Okay? There's the inequality symbol, there's the inequality symbol. This is the middle portion. The 4x plus 3 is the middle portion. The other 2 are the ends. So if I subtract 3, I'm going to get negative 8 is less than 4x, which is less than 2. Now divide by 4. Make sure you divide all parts of it. Negative 8 divided by 4 is negative 2, which is less than x, which is less than 1/2. So I now have x between negative 2 and positive 1/2. And those you can graph just as easily as you can graph whole numbers. And I'm just going to graph this very simply, letter B. Negative 3, positive 3. It's greater than negative 2, so here's negative 2, open circle. Less than 1/2, closed circle at 1/2, line between the 2. And we're done. Simple as that. Let's take a look at letter B. I have the absolute value of 2x plus 6 is greater than or equal to 10, which means that's the greater, so it's the pink one. So I'm going to set it up so that A, which is 2x plus 6, 2x plus 6, is greater than or equal to 10. Or, you write it again, A, 2x plus 6. Reverse your inequality symbol is less than or equal to, and reverse the negative here. Okay? So you're going to write it just as you see it, that would be here. And then you're going to write it, reverse the sign, that would be there. Notice how I did that. I wrote it exactly as you saw it. 2x plus 6 is greater than or equal to 10. Or, keep the 2x plus 6, reverse the inequality symbol, and reverse the sign on the number after the inequality symbol. So now we can solve this. Subtract 6, subtract 6. 2x plus 6 is greater than or equal to 4. Oops. Sorry, this is silly me. Let's try that again. 2x is greater than or equal to 4. Divide by 2. X is greater than or equal to 2. Over here, subtract 6, these will cancel out. 2x is less than or equal to 16. Divide by 2. X is less than or equal to negative 8. So x is greater than or equal to 2, or, okay, or x is less or equal to negative 8. So there's the answer to the inequality. Now we actually have to graph it. So x is greater than or equal to 2. Well, so equal to 2, the line to the right. Less than or equal to negative 8. Well, it's equal to negative 8, line to the left. You must remember when you have an absolute value inequality, you will have two solutions. So you have to write them both. Now, this next problem is a bit more complicated because before we can set it up, we actually have to simplify it. Okay, so I have two absolute value 4x plus 1 minus 5 is less than or equal to 1. So I have to get rid of the 5 first. So I have to add the 5 and then get rid of division and subtraction first, multiplication and division second. These will cancel out. I have 2 absolute value of 4x plus 1 is less than or equal to 6. Now divide everything by 2. Don't distribute that. That will mess it up massively. These 2 cancel to that 2. So I now have the absolute value of 4x plus 1 is less than or equal to 3. It's a less than, so it's an and, so we're going to write it exactly as we see it first. 4x plus 1 is less than or equal to 3. Then move this sign to the front. Greater than or equal to, move the number to the front, but make it the opposite. That's what we did. We wrote it exactly as we saw it, and then move the symbol to the front of the 4x, and then move the 3 and put in front of the symbol, but make it the opposite. Now we can solve this. Subtract 1, subtract 1, subtract 1. Negative 4 is less than or equal to 4x, which is less than or equal to 2. Divide by 4, divide by 4. And negative 1 is less than or equal to x, which is less than or equal to 1/2. So x is between negative 1 and 1/2. Angles are very, very close to each other. So I'm just going to do this. 0. Here's negative 1. Here's positive 1. X is greater than or equal to negative 1, less than or equal to 1/2, and a line goes between them. Make sure you number your number lines so that you can follow it. And this would be our solution, both the inequality and the graph itself. Now we're going to go into tolerances. Okay? A manufactured item's actual measurements and its target measurements can differ by a certain amount. This is called the tolerance. When they say that a box of cereal weighs 16 ounces, they can be off by a fraction of an ounce either direction. That's called a tolerance. So if you go home and weigh the contents of your box and it only weighs 15.92 ounces, it may be within the tolerance. You can't go and complain that they gypped you out of 0.08 ounces because it could make it be within what they call the manufacturer tolerance. Tolerance is 1/2 of the difference of the maximum and minimum acceptable values. You can use absolute value inequalities to describe a tolerance. Okay? Let's say you're cutting pieces of wood to make a table. Each piece should be 4.75 feet, 4 3/4 feet. But you will use a piece if it's greater than 4.7, but less than 4.8. It can be between 4.7 and 4.8 and work. Okay? So, what we need to do is what absolute value inequality describes the tolerance of the length of the wood. So let's first find the tolerance of the length of the wood. And remember, tolerance is 1/2 of the difference of the maximum and minimum acceptable values. My maximum acceptable value is 4.8, my minimum is 4.7, and we're going to do half of that. Okay, 4.7 minus 4.8 is 0.1. 0.1 divided by 2. That's the same thing as saying 1 over 20. Which is the same thing as saying 0.05. Okay? I don't care how you write it. Any of those ways will work. Just don't use the 0.1 over 2. You can't have a decimal within a fraction. So either use the 1/20th or the 0.05. So that's my tolerance. Okay? That is my tolerance. So I'm going to write an absolute value inequality that describes my tolerance. Okay? So I'm going to let x equal my acceptable lengths. Ooh, I can spell. Okay, so we can be off by 0.05. Okay? So I'm going to take what I want. This is The 4.75 is the ideal. That's what you'd love to have every single time. You're not going to get it every single time. So you'll allow it to be as low as 4.70 or as high as 4.80 because your tolerance of 0.05 either direction. Okay? 0.05, it can be off by 0.05. So I know that if I take my acceptable length and I subtract 4.75, my ideal length from that, okay, my acceptable length minus my ideal length, the absolute value of that, has got to be less than 0.05. Okay, and that is your inequality that describes the tolerance. My acceptable lengths minus my ideal lengths in an absolute value, which means it's always going to be positive, has got to be less than 0.05. Take a look at another one. This one's going to step you through a little bit more. The diameter of a ball bearing in a kilocentery must be between 1.758 centimeters and 1.764 centimeters. What's the tolerance? Well, to find the tolerance, the first thing you need to do is take the maximum and minimum, subtract them. So the tolerance is going to be 1.764 minus 1.758 and divide that by 2. Okay, so we take 1.764 minus 1.758. Okay, 1.764 minus 1.758 is 0.006. 0.006 divided by 2, you're going to get 0.003. So my tolerance is 0.003 centimeters. That's how much I will tolerate it being off. What is the absolute value of inequality that represents the diameter of the ball bearing? Let D represent the diameter in centimeters. So if D is the diameter in centimeters, we need to find the ideal length. If the ball bearing can be between 1.758 and 1.764, the ideal will be taking the larger length and subtracting 0.003, or taking the smaller length and adding 0.003, doesn't matter. So I'm going to take 1.764 and subtract 0.003, and my ideal length, or my ideal diameter is 1.761. That's my ideal diameter. And if you remember, your ideal minus, right, the acceptable diameters minus my ideal diameters in absolute value has got to be less than my tolerance. Okay, acceptable minus ideal in absolute value has got to be less than your tolerance. That's the equation for finding the inequality, the absolute value of inequality for a tolerance problem. My acceptable, okay, is going to be D. My ideal, 1.761, that's in an absolute value, has got to be less than my tolerance, 0.3. There you have the inequality, absolute value inequality that works for that tolerance.